All right, everybody. We are going to do a whole bunch of practice with mixed naming and writing formulas for a mixture of ionic and covalent compounds. If I was here in class today, we would do this as speed dating. The best I can do in this format is to tell you to pause the video after each example that I present to you and work on it with the group that you sit with, and then we'll start the video again and we'll go over this thing. Make sure you have all of your periodic tables and any notes that you have, the flow charts, all of your resources handy as we do this. So on each set, I'm just going to give you two examples. The first thing you should do is decide if they're ionic or covalent. After you've decided if they're ionic or covalent, you should use the correct system to either change the name into a formula or the formula into a name. Let's get this started. So here's your very first one. Pause the video right now and work on this. All right, we're back from pausing the video. So as we look at this, I see in this one that we have got prefixes. And anytime there's prefixes, we're talking about a covalent compound. Those prefixes are telling me what kind of, or how many of each of those things we have. So phosphorus, it says di, so there's two of them. And chlorine has got a penta, which means 5. Okay? Then on the next one, I look at this formula right here, and again, the thing we look for when we're looking at formulas is there any metals in there? If there are metals in there, it's going to be ionic, and potassium comes from the left side of the periodic table. That means it's a metal, so it's going to be ionic. So we simply write the name of the metal, potassium, and then we write the name of the non-metal, changing its ending to an IDE ending. So oxygen becomes oxide, potassium oxide. All right, let's erase that. Maybe not. Holy smokes. Good, let's go to the next slide. Pause the video and work on these. Okay, so as we look at these first ones here, I have carbon and oxygen. Carbon and oxygen are both nonmetals. I also see that there's a prefix here, and again, prefixes only happen for covalent compounds. So I'm using my covalent naming rules. Now, there's no prefix in front here. When the no prefix right there means mono. Remember, we never use mono on the first element. So it means one single carbon, and then the mono here means one single of these things. That's oxygen, oxide. Carbon monoxide looks like that. Coming down here, I see that I have N, which is nitrogen. That's a nonmetal from the right side of the table. And fluorine, that's also a nonmetal from the right side of the table. So we're talking about a covalent compound here as well, and now I got to bust out my prefixes. Now taking the cue from up above here, if there's mono on the first one, like I have one nitrogen here, that means I'm going to just write, not carbon, this is a different one, nitrogen. We're talking about nitrogen here, but I'm going to leave the mono off of it because we don't ever put mono on the first element. Okay, and then I see that I have got two of the fluorines here, so I'm going to put a di in front of that. Difluoride. Nitrogen difluoride. Okay, let me clear my ink here. We'll see if this works. Clear ink. Oh, that's way better. All right. I'm going to go forward a slide. Pause the video. All right, let's look at this one. So we're looking at this, I see calcium. Calcium is from the left side of the table. It is a metal. That means it's going to be an ionic compound. All right, now calcium, and it's with sulfur. I see the ending is changed to IDE. Now with ionic compounds, I need to think about charges when I write the formulas. So if you look on your table, you'll find that calcium forms ions with a +2 charge, and that sulfur forms ions with a -2 charge. That's real cute. If this is +2 and that's -2, when I bring one of each of them together, their charge will be 0, and that is the whole goal with an ionic compound, is to get the charges to balance out so that they have 0 charge when they are together. So we just have one calcium and one sulfur. Moving down to the second one here, when I look at this, I see phosphorus. That's our nonmetal from the right side of the table, and oxygen, which is a nonmetal from the right side of the table. This, friends, is a covalent compound. So we are going to use the prefixes di in front of the phosphorus. So diphosphorus, winged spawn of Satan, and 4 is tetraoxide. Diphosphorus tetraoxide. All right, let's clear this one off. Hello. Hello, clear this one off, clear ink. Great. Go forward a slide. Pause the video. All right, come on back. We're looking at this guy. I'm seeing that there is prefixes like di and tetra. Whenever I see prefixes, I know I'm talking about a covalent compound. Nitrogen has a di in front of it, so the di means 2, so there are 2 nitrogens. Tetra means 4 of what? 4 of oxygen. Dinitrogen tetraoxide. So that's real cute. Then I come over here and I look at this. I'm like, all right, lithium is from the left side of the table. That's a metal. A metal means that we've got an ionic compound here, and so we are going to write the name of the metal first. Lithium. And then we are going to go on and we're going to take the name of the nonmetal, which is going to be sulfur, and we're going to end it in IDE. We're chopping off the end of the name and changing it to lithium sulfide. Okay, let's clear our ink. Hello. Let's advance our slide. Pause the video and work these out. And we're back. I'm looking for magnesium on my chart, and I find on the left side magnesium is a metal. We probably know that actually. Magnesium is a metal, which means we're talking about an ionic compound. So, ionic compounds involve charges. Magnesium makes ions with a charge of +2. It loses 2 electrons and makes a magnesium ion. Now, chlorine has, it's a nonmetal over on the right side there, it makes -1 charges. Okay, this is the hardest one so far. So our goal here is to make these guys get together, and when they get together, have 0 charge. So having 1 magnesium and 1 chlorine is not going to do it. Since magnesium is a +2 charge, I'm going to come over here and I'm going to take 2 chlorines, because together, the -1 and the -1 together would be -2. +2 and -2 are going to go together to be 0. So when I draw this compound's formula, it's going to be 1 magnesium and then 2 chlorines. That's the formula for magnesium chloride. Moving down to the second one here, I see carbon, which is a nonmetal, and fluorine, which is a nonmetal. This is a covalent compound. Carbon and fluorine are getting together in a covalent way. We would say carbon, and again, we don't put the prefix in front because it would be mono, so we leave it off. We never put mono on the first element in a covalent compound. And the second one is fluorine. I got 4 of them though. So the prefix for 4 is tetrafluoride. Carbon tetrafluoride. Okay. Clear this ink. Advance the slide. Pause the video and work these bad boys out. Okay, and we're back. We look up strontium. Strontium is from the left side of the table, means it's an ionic compound, means we have to deal with charges here. So strontium is an alkaline earth metal, and they all form charges of +2. So strontium loses 2 electrons and makes a strontium ion. Okay, and it's with phosphide. Phosphide, remember the IDE ending was changed, so phosphorus is probably what we got here. Phosphorus is a nonmetal, and when it forms ions, they are -3 charged. Holy smokes, this is going to be a doozy. Strontium phosphide, I think about the least common multiple of 2 and 3, and I get 6. I want to make these guys have 0 charge. In order to do that, I'm going to want 3 of the strontiums, because +2, +2, and +2, +2, +2, +2 is going to give me a charge of +6. And I know that if I take 2 of the phosphides together, they would have a charge of -6. So I need to write this formula with 3 strontiums and 2 phosphoruses. And when we have 3 strontium and 2 phosphoruses, there is no charge here. And so we don't have anything listed there. We got a charge of 0. Coming down to the next one here, I see Ba. Ba is barium. Barium is also an alkaline earth metal. And so we are going to, it's a metal. This is an ionic compound. We are going to write its name, barium. That's what you do after you shootium. And then you are going to give me the oxygen, which has its name changed to ide, oxide. Okay, let's clear ink. Hello, clear ink. And let's advance the slide. Pause the video, work these guys out. And we're back. Cesium. Cesium actually has a couple different spellings depending on what side of the lake you live on. Cesium is a metal that makes this an ionic compound. So cesium is an alkali metal and they have charges of +1. You can find that on your periodic table, the yellow one. And then with fluorine, fluoride would have a -1 charge. This is real cute. If cesium's a +1 and fluoride's a -1, we just need one of each of them. Cesium fluoride looks like that. Okay, looking at our next one here, we have nitrogen, a nonmetal, and iodine, also a nonmetal. So we are talking covalent compound here. Covalent compound, it's going to be nitrogen, not mononitrogen. Never use mono in the first one. Nitrogen, and then the iodine, there's 3 of them. So tri, because there's a 3 there, triiodide. Nitrogen triiodide. That's some pretty fun stuff, actually. All right, we're going to clear ink. We are going to advance the slide and pause the video and work these out. We're back, and I see that the di and the mono here indicate that we have got a covalent compound. So this is a hydrogen. It says that there is a di, 2 of them, and then this is ox. That means oxygen, and there's just 1 because it says mon on there. So good old H2O for that one. For the second one, we have silicon. Now, silicon is a metalloid. So is that a metal or a non-metal? It's, it's a kind of a toss-up. If you look on the staircase, you'll find that silicon is on the right side of the staircase. We're going to name this as though it is a covalent compound, and I'm just going to call this silicon dioxide, which is the name that we would normally use for this thing. Although I wouldn't, necessarily blame you if you tried naming this as an ionic compound, because we have a metalloid involved here. It's hard to say what silicon is, metal or non-metal. It's neither, really. Clear the ink. All right, and advance the slide. Here we go. So, pause the video. We are back. Sulfur is a non-metal. Oxygen is a nonmetal. I also see this prefix here. All of these things lead me to think this is a covalent compound. Sulfur dioxide. So sulfur must be just 1. I don't see any prefix there, so that indicates it's a mono, and it would just be 1. And then the dioxide tells me that the oxygens, there must be 2, because di means 2. All right, and the next one. Bieber. Oh, don't get me started. Beryllium is a metal, and so that means this is going to be an ionic compound. So beryllium, and then the bromine will become brome. Change the ending to IDE, bromide, beryllium bromide. Let's clear the ink. Slide. All right, pause the video and work these guys out. We are back, and we know that aluminum from everyday experience is a metal, which makes this an ionic compound. So, ionic compounds, when we write formulas for ionic compounds, we need to think about charges. So you find on your periodic table that aluminum forms ions with a +3 charge. It is being paired here with oxides. On your chart, your oxides will show you that they have a -2 ions. Oxygens pick up 2 electrons, so 2 extra electrons give them a -2 charge. This is another one of those ones that's going to be kind of ugly. With +3s and -2s, I'm thinking about 6. 2 aluminums gives me +6, and 3 oxygens give me -6. So when I write my formula, I have to say, to make a compound with no charge, we would need 2 aluminums and 3 oxygens. Aluminum oxide looks like that. Coming down to the next one here, I see that I've got calcium, and calcium, believe it or not, is a metal. It comes from the left side of our periodic table. This is an ionic compound. No prefixes, please. Calcium fluoride. Done! Clear the ink. Advance the slide. Pause the video. Come on back. So, magnesium. Magnesium is a metal. That means this is an ionic compound, and we have to think about charges. It's with nitrogen here. So, magnesium, being an alkaline earth metal, forms ions with a +2 charge. Looking on your periodic table, what